In this video, I'm going to discuss about the confidence interval of population proportion. From the previous video, we know that this shaded region is the probability of error where the interval produced does not include the population parameter, which is alpha over 2. And this is the probability where the interval produced contains the population parameter, which is 1 minus alpha. And from this diagram, we know that the interval is z is greater than negative z over 2 and less than z over 2. And since we know that the distribution of the sample proportion is approximate to normal distribution under central limit theorem when n is sufficiently large, where the mean is the population proportion p and the variance is PQ divided by sample size n. Now I'm going to change the z back into the sample proportion where z is equal to ph minus p divided by the standard deviation. Then I shift this one to the left and right, then I get this. Next, I'm going to shift the ph to the left and right, and when I change the p to positive and rearrange the inequality, then I get p is greater than this one and less than this one. Therefore, the confidence interval for the population proportion is the interval from ph minus z times the standard deviation until ph plus z times standard deviation. But for this confidence interval, we found that we have got one problem. That is, we do not know the values of the population proportion P. So, to overcome this problem, we are going to use the unbiased estimate of the population proportion PH to estimate the population proportion. So therefore, this is the confidence interval for the population proportion. So therefore, when finding the confidence interval of the population proportion, first we are going to find the sample proportion pH, where pH is equal to k over n, where k is equal to the number of success element in the sample and n is the sample size. Then we are going to use the pH as the center to find the lower limit and upper limit in order to find the confidence interval. Now we proceed to the example. A supervisor wants to know the proportion of defective electronic components produced by a machine. He inspects a random sample of 200 electronic components and found that 40 electronic components are defective. Find a 95% symmetrical confidence interval of the proportion of defective electronic components produced by the machine. Comment on your answer. So first I'm going to find the sample proportion, that is pH. pH is equal to the number of success element. The number of success element is the number of the electronic components that are defective. So it is equal to 40 and sample size is 200. So pH is equal to 0.2. And next, we are going to find the Z value. Since the confidence level is 95%, that is 0.95. So alpha is equal to 1 minus 0.95. It is 0.05. Alpha 2 is 0.025. And from the normal table, we find that the Z value is 1.96. Now, to find the 95% confidence interval for the population proportion, now we are going to substitute all the values that we have. That is, pH is 0.2, Z is 1.96, pH 0.2, 1 minus pH is 0.8, N is 200. Then when I calculate, so the confidence interval is from 0.145 to 0.255. And to comment on this confidence interval, so I can say that we are 95% confident that the proportion of the defective electronic components produced by the machine is between 0.145 and 0.255. And beside this, we can comment the other way. That is, we are 95% confident that 14.5% to 25.5% of the electronic components produced by the machine is defective. Now we proceed to the second example. A dog training school has a larger than average proportion of clients who compete in competitive proportional events. A confidence interval for the population proportion of dogs that compete in professional events from 150 different training schools is constructed. The lower limit is determined to be 0.08 and the upper limit is determined to be 0.16. Determine the level of confidence used to construct the interval of the population proportion of dogs that compete in professional events. From the question, we are given the upper limit and lower limit of the confidence interval of the proportion, where the lower limit is 0.08 and the upper limit is 0.16. First, we are going to find the pH. And we know that pH is the midpoint of the interval. Since interval is given, so we can calculate pH is equal to 0.08 plus 0.16 divided by 2. That is equal to 0.12. Next, we are going to find the alpha. To find the alpha, then we have to find the Z. Since we are given the lower limit and upper limit, so we can use either lower limit or upper limit to do the calculation. Now I choose upper limit. So when I substitute the pH, where pH is equal to 0.12, 1 minus pH is 0.88 with the sample size 150. And when I calculate, Z alpha over 2 is 1.5076. With this value of Z, now I'm going to find the alpha. When we look at this diagram, the shaded region here is alpha over 2. That is the probability of Z greater than 1.5076. That is the probability of this shaded region. It is equal to alpha over 2. And Z greater than 1.5076 actually is equal to 1 minus Z less than 1.5076. And from the normal table, it is equal to 0.066. So actually this 0.066 is equal to value alpha over 2. Therefore, alpha is equal to 0.132. Based on this value of alpha, now we are going to find the confidence level, where the confidence level is 1 minus alpha percent. So when we calculate, 1 minus alpha is 1 minus 0.132. That is, the percentage is 86.8%. Next example, the proportion of car drivers taking lead-free petrol at a particular filling station has been found to be 0.42. following an increase in the tax on other types of fuel, a random sample of 120 cars was observed at the filling station. The number of drivers taking lead-free petrol was found to be 58. Find a 95% symmetrical confidence interval of the proportion of drivers taking lead-free petrol at the filling station. Hence, determine whether there has been a change in the proportion of drivers taking lead-free petrol at the filling station. First, I'm going to find the sample proportion, that is pH. That is equal to 58 divided by 120. It is equal to 0.4833. Next, I'm going to find the Z value. Since the confidence level is 95%, that is 0.95, so alpha is equal to 0.05. So therefore, alpha over 2 is 0.025 and the Z value is 1.96. Based on the formula of the confidence interval of the population proportion, now I'm going to substitute the values of pH and value of Z and 1 minus pH. So when I calculate, the interval is from 0.3939 to 0.5727. And based on this interval, now I'm going to determine whether there has been a change in the proportion of drivers taking lead-free petrol at the filling station. And we are given that the original proportion is 0.42. So when we look at the interval, we find that 0.42 is in the interval. So therefore, 0.42 is not rejected. So conclusion, at 95% confidence level, there is insufficient evidence to conclude that the proportion of drivers taking lead-free petrol at the filling station has changed.